So one problem with the PCR OR is that we would have to know when we write the file or when we create the storage key, what the values of the PCRs are going to be after the update. There's actually a way around this using the policy authorization, and I don't really think it's unreasonable that we could do both of them, but this would probably be a more powerful and more adaptable method. So the first step is to create the signing key. The second step would be to create a PCR policy. Then we have to authorize the policy. Then we have to sign the policy. Then we have to authorize the policy. Then we would create the storage key. So what we would be doing is trying to verify the signature and then use the authorized policy to unseal. And that is basically it for the initial setup of everything. But then, in the future, anytime we do an upgrade to the firmware or whatever, we would need to create a new PCR policy, sign the policy, authorize the policy, verify the signature, and then finally use the authorized policy. So basically, we're creating a policy where the contents of the policy can be changed if they are signed by whoever has the signing key. So the first thing we're going to do is create the signing key using OpenSSL, generate a RSA key. This is going to be the out. And then the output is going to be signingkey.priv.pem 2048. And this is only the private portion of the RSA key. And this doesn't have anything to do with the TPM. We're just creating an asymmetric key. Open SSL RSA in signing key priv.pem. And then we're going to be outputting a public signing key and then pub out. So we're using that private key to create a public key. And then by ls, I have, this is the secret, just the text file that I'm going to be encrypting later. And then we have this, and then we have the private and public key. So now if I do tpm2 load external grsa signing key pub.pem context signing key name.name. So we're indicating that we're loading an RSA key here. Again, we're using the owner hierarchy. This is going to be the public portion of the key that we're using to sign. This is going to be a context object, and this is going to be a name that will be created in order to reference that object. It does give us a warning, but it's not a complete error. Everything works fine. It does the conversion of data types for us. And then, so now we have signing key.name and signing key.context. So we've done step one of creating the signing key. Then we have to create the privacy policy. So tpm2 pcr read pcrs.sha256 012. And all this is going to do is read the PCR values I have right now and put them in this data file. So this is the PCR values I have now, all zeros, and they're stored in this file. So if I do tpm2 start auth session, tpm2 policy PCR, erase what I just said, and then tpm2 policy PCR session.context SHA-256 0, 1, and 2 PCRs.data, and then this is going to be the output. So I'm going to call it PCR1.policy. So this is the same thing we've done before. We're reading this file with the PCR values in it. This is the selection of those values. And then the output is going to be the actual PCR policy. Then I'm going to go ahead and flush context. So the next thing we have to do is sign the policy and authorize the policy. Signing is OpenSSL digest SHA-256, signing key, private, and PCR1.policy. So we're just going to be signing the key using the private portion of the signing key. We're taking in the PCR1.policy as an argument, and then we have the output with the PCR.signature. So the next thing we have to do is authorize the policy. tpm2 policy authorize.policy signing key.name. So here we're just taking in the session object. This is going to be the outputted authorized.policy, and then this is the key that we've been using this entire time. I'm going to go ahead and flush. So now we've done 3 and 4. We need to actually create the storage key. tpm2 create SHA-256, and then the parent is going to be the storage root key, which I have in persistent memory already. So I refer to it with that handle. And then here we can call this storage key.pub. And then this is going to be the private version, so storage key.priv. And then the input file, which is called secret. And then the output is going to be called tpm2 flush context. I'm going to try that same command again. And it created the storage key. So now we just need to verify the signature and use the authorized policy to unseal. So to verify, we just do tpm2 verify signature. We pass it the signing key.context, SHA-256, PCR1.policy, PCR1.signature, verification.ticket, and then RSA SSA. So we're passing in the context. Here we just have the hashing out. So we're passing in the context. This is the algorithm that we're using. This is the actual policy digest. So between the policy and the signature, it can verify that we used that key to sign this policy. And then here's going to be an output. And it's basically going to be a ticket saying that the TPM has verified that we are who we say we are, or that we signed it. And this is the scheme that was used to sign the message over here. So I actually called this PCR.signature. And then now we can start another auth session in order to verify and hopefully unseal the data. So again, we have to pass it a policy session because we're actually checking to see if everything matches up. And then tpm2 policy PCR session.context SHA-256 0, 1, and 2 lpcr.policy read. So this is going to be the actual PCR values that we have in right now. They don't have anything to do with the authorized values that we created earlier in PCR1.policy. But then we can do tpm2 policy authorize session.context authorized.policy, which is going to be the output, PCR1.policy, which has all the 0 values in PCR 0, 1, and 2. And then here we're going to do signing key.name, t verification.ticket. So here it's taking that verification ticket that we created, saying that, we have officially signed everything, and it's also taking in that signing key and the policy that we created and signed, and it's going to authorize this policy. So now when we do tpm2 load, and I'm going to refer again to the storage root handle, which is the parent key to this key, because I'm going to be referring to the storage key.public and the storage key.private and storage key context. And I'm already thinking I don't have enough room in main memory, so I'm going to try this, but yeah, that didn't work. All right, so once again, I need to do tpm2 context flush context. So one more time, trying that again. I'm now trying to load the storage key that has our encrypted message in it. And now hopefully I can do tpm2 unseal session.context. And then this is going to be called filling key and this should be storage key context. And you can see I got back the encrypted message. And that is all great. We've only tried it with one set of PCR values though. So what I'm going to do is go ahead and extend to some other values. And it really doesn't even matter what these values are. That's kind of why this is a lot better than policy OR, because I don't even need to know what the values are. I don't need to predict them when I create the key. I can just put new values into the policy. So here we're going to create one more PCR policy, and then PCRs.data, SHA-256, 0, 1, and 2, tpm2, start auth session. I copied all of the current PCR values into this PCR.data file. Here we created an auth session, and then we're doing policy PCR. This is the PCR selection. Here's the file that we're reading in, and then I do some garbage collection. And then the next thing we have to do is sign the policy, which is exactly like the signature that we did before. We do open SSL, digest, SHA-256. We need to have the private portion of the signing key here, and then we can output it. I called this PCR new.signature and PCR2.policy. So this is going to be a new policy using these values. But really, these could be any values at all. If I do another extend, I can just do this whole process again. And when I created the key, like 5 minutes ago, I didn't need to know what these values are going to be. So again, we're going to do tpm authorize. So we're going to do a auth session, tpm2 policy authorize, session.context, authorize new, dot policy, signing key, dot name. And these are all arguments we're going to have to pass in when we convert this all into C code. So we have policy authorized to session context. This is going to be the output. which I did not call a policy, and then the signing key. And then here, TPM2, and then garbage collection. And let me look in the RAM. I have these handles. I'm going to go ahead and TPM2 flush. And I had a problem earlier when I didn't do this load external step here because I believe that the signing key needs to be referenced somewhere in the TPM in order for this to work. So TPM2 load external, this is the type of key, owner hierarchy. This is the public portion of the signing key. This is the context of the key. This is the key context object, and then this is the name of the key. And if I do TPM2 getCap handles transient, this is the key right there. And I'm pretty sure that any object that you can put in RAM, you can also put in persistent memory if you want to. I'm going to go ahead and skip that step for now, but it is possible. And then now if I do verify signature, signing key.context, SHA-256, PCR2.policy, PCR new.signature, verification.ticket, RSA, SSA. It's the same thing that I did earlier. We have the signing key context, which is already loaded in main memory here. We have the algorithm. This is going to be the new policy, which has already been signed along with this new signature here. And then it's going to output the verification ticket. And this is the signing scheme right here. And we might not actually need this argument. Depending on what kind of signing key we use, they have certain data types that are approved by the TSS. And now all I need to do is one more auth session. This is going to be another policy session to check that everything matches up. TPM2 policy PCR session.context L SHA-256 012 PCR.policy read. So now I'm reading in my current PCR values into this policy. TPM2 policy authorize session.context authorized.policy, and then PCR2.policy, signing key.name, verification.ticket. One more time, taking in the verification ticket that was outputted when we did the verify signature step, and taking it as input along with the signing key and the new policy. And we're saying that this is now the authorized new policy, and this is going to be the file that gets outputted. And let me clear TPM2 flush context, and let me make sure that I have enough room to load in a key. So now I can do TPM2 load C, again referencing the storage root key, and then here we're going to do storage key, the public version, and then the private filling key dot context. And now finally, if I do TPM2 unseal session, and then I pass in the sealing key, you can see that I get back my encrypted message. So I didn't use the policy or, and more importantly, I didn't need to know what the values of my new PCR registers are. All I needed to do was have access to the signing key and then create a new policy and basically replace the old policy. And basically authorize that new policy to unseal the data.